So this video is going to quickly review the correlation coefficient, and that's given by the letter R, and it's basically telling you the strength of your linear relationship, and R values are between +1 and -1. So a negative relationship has a negative gradient, it's going top left to bottom right, and a positive relationship has a positive gradient, it's going bottom left to top right. So if we look at this one here, this is a perfectly positive correlation of R is 1, so it's completely straight. Okay, so if you know linear equation stuff, you would have a perfectly straight line given by y equals a plus b times x. Now, if the scatter plot does not have a perfect relationship, or perfect association, it's going to be less positive. It's going to be between 0.75 and 1. So R values between 0.75 and 1 look something like this if it's positive. And even smaller R value between 0.5 and 0.75, we've got a moderate positive relationship, so it's a bit more random. Going down 0.25 to 0.5, a weak positive correlation. Okay, it looks like it's going up, just again a bit more random. And between 0 and 0.25, there's almost no correlation. Okay, it looks very random. And the same thing happens if we're looking at negative R values. So this is a perfectly straight negative scatter plot association, and becomes less and less, less and less, less and less. And again, the same sort of values apply, but it's got a negative there because it's going down from top left to bottom right. Now, when you're commenting on a linear association, if you think it's linear, you need to comment on the direction and if there's any outliers, any significant things that look out of place. Form, is it linear or non-linear? Does it look like it's going up in a straight line or not? And strength, strong, moderate, or weak. Now in practice, in most cases, you'll be using a CAS to calculate the R value. Okay, and then you determine if it's strong, moderate, or weak based on those values up here. Okay, now there is a caveat, so you can only use the correlation coefficient if variables are numerical, okay, for both response and explanatory. So the explanatory on the horizontal, response on the vertical. So the thing being predicted is on the response. The association is linear, okay, so it has to look linear, and later we'll look at how to determine if it is linear or not. And there must be no outliers, okay? Those conditions must be satisfied in order for you to use the correlation coefficient. Now, we'll just quickly look at the Ti Nspire. Now, if you go into your spreadsheet here, then we need to be able to work out our value using the CAS. So you need to label your categories. Say it was 2 tests in an exam period. Okay, test 1. If you do well on test 1, then you should do well on test 2. That's kind of like an association. So say it was out of 20, this guy got 19 on the first test, 19 on the second test. This guy got 17 on the first test and 18 on the second test. This guy got 15 on the first test and 14 on the second test. 13 and 14, 16 and 18, 12 and 9. Okay, so I'm just putting some data values in there. Now, what you need to do in order to get your R value with the CAS is go into menu, okay, statistics, stat calculations, and we're going to go linear regression a plus bx, okay. The x list is your explanatory, and let's say it's test 1 is your explanatory and test 2 is your response. Then you press OK, and what comes up is these values here. So later you'll see this is the a value, which is like the y-intercept, b value is the slope, r squared is this thing called the coefficient of determination, and this r value is the correlation coefficient. So you see this has a strong positive association. So if I looked at it as a scatter plot, if I went Control I, and then go add list, add data and statistics, put my explanatory here, so explanatory there, and response there. It looks like a straight line, okay, and it has a strong positive relationship. Okay, so that's a quick review of the correlation coefficient and R values.